Let's now move on to character variables. A character represents a single character. It could be a letter of the alphabet, uppercase and lowercase characters, special symbols such as plus, dollar sign, exclamation mark, and so on, and numbers or digits from 0 to 9. So all the characters in C, C++ have to be enclosed in single quotes. Remember, strings are enclosed within double quotes and characters are enclosed in single quotes. So if you look at a initializer, so I have a character letter, I am initializing it to capital A. Then I am initializing it to digit 9. And then you could also, declare and initialize at the same time. So you could say character letter is equal to C. In fact, remember, character is nothing but a natural number. It's a 1 byte natural number, meaning that you can store values between -128 and 127. We already have looked at it. So what's actually stored when you say letter is equal to capital A is the ASCII value or the index of this character within the ASCII table. So A has an index of 65, B has an index of 66, and lowercase a has an index of 97, and the 0 digit has a index of 948. So let's look at the ASCII table. This is a table that has 127 characters in it, actually 128, starting with 0. So 32 of them, the first 32, so this is 0, 1, 2, F until F. This is 16 characters on the first line, 16 characters on the second line, and so on. So there are 8 lines and 16 columns. So if you multiply them, that would be 128 characters. And you can see that, the first 32 characters are not printable. So if you try to print these, you're not going to see, these characters on the screen. So the first printable character is the space character, which has an index of 32. So you can see the index or the value of this character 32 on top of, the character itself. And look at 0, the digit 0, that has an index of 48, ASCII value of 38, and capital A or uppercase A has an ASCII value of 65, and lowercase a has an ASCII value of 97, as you can see. So the special characters are here, like dollar sign, the parentheses symbols, and so on. So bottom line is, when you say letter is equal to a. So let's go back in here. When you say letter is equal to a, what the compiler does is it goes back to the ASCII table and picks up the ASCII value of this character and stores it in this letter. So I could have easily said 65 in here instead of saying A, and that would have meant the same thing, because the compiler is essentially, when you say, when you specify the character like this, the compiler is essentially doing the same thing, taking the ASCII value of the character and storing it in this character letter. And remember, a character, although it might indicate that you might be storing a character in there, it's just a 1 byte variable. So you're just storing an integer. So you might be storing 5, -5, although -5 is not a valid character, you could store -5 because it's just a 1 byte variable. Let's look at an interesting problem when working with characters. Remember, characters in C++ have to be enclosed within 2 single quote characters. But then how do we denote a single quote character, right? Is this okay? What do you think about it? So look at it. So we are basically trying to represent the single quote character. So we open the character with a single quote. We have to close it with a single quote and then put a single quote in between. So does this make sense? The answer is no. So think about it. How would the compiler know that this second single quote character is actually representing the single quote character, rather than closing the whatever the character that we would like to put in here? So this just doesn't make sense, and there has to be a solution for it. The solution that C programmers actually found was to escape it. So this is called an escape sequence. What you do is you put a backslash character in front of the single quote character. Now it makes sense, because when the compiler starts parsing this line, it sees that a single quote opens the character, then sees the backspace, meaning that the character that comes after backspace has to be interpreted, has to have a special meaning. And the special meaning is it represents a single quote character. So this is not representing the end of the character, but rather it is representing the single quote character now. And the second single quote character is going to close it up. So that's the solution that they found. These are called, the backslash is called a the character with a backslash in front of it is called an escape sequence or a special character in C, C++. And a lot of the programming languages that came after C has adopted this convention in a sense. So almost every other programming language that you learn later on, like Java, maybe Python, C Sharp, any other JavaScript. So all those programming languages adopted this convention. So what you have is now a escape, special characters that exist in all of these programming languages. And we have already seen one such special character, which was the new line character. So by putting this escape sequence or the backslash character in front of n, we are giving a new meaning to the character n. Without the backslash character, n is an n character, but when you put a backslash in front of it, you're making it you're giving it a special meaning, meaning that it's a new line character. So when printing a escape sequence, a backslash n, instead of just printing n on the screen, we are now printing a new line character and taking the cursor from wherever it is on this line and bringing it to the beginning of the next line. And these are the other backspace escape sequences that you will see in almost all programming languages. Here's an example where I make use of all of these special escape sequence characters and print them on the screen. This is example 2 under string literals, and that's this file. So if you go there, I'm just creating strings that contain these escape sequences, and I'm going to go step by step so that you see how they are printed. So I'm going to put the breakpoint in here, come in here and say debug. So let's look at the first line. The first line has the debugging started, the control stops at this first line, and I'm going to go step by step so that you can see how this is executed. Think about it. This string has backslash n, which was the new line character. So what we should see on the screen is here, then the cursor goes to the beginning of the next line, then then again the cursor goes to the beginning of the next line and go. And then again the cursor goes to the beginning of the next line. So let's execute this and you can see it. Here we go, and now the cursor is right here. So I'm going to print some separated characters between each of these printfs. So let me do that because it has also the new line character at the end. Now the cursor is right here. This time, instead of using backslash n, I used carriage return. The difference between new line and carriage return is carriage return takes the cursor to the beginning of the same line rather than taking it to the beginning of the next line. So what will happen is here will be printed, right? So you'll see here on the screen. Then we are printing a carriage return which takes the cursor to the beginning of the same line. Then we will be overwriting here. So then when we say we should overwrite here, right? Then again we are taking we are printing another carriage return character that again takes the cursor to the beginning of the same line. Then we print go and 3 dots. So that should also overwrite v now, and we should just see go ... on the screen, and at the end we have the new line character that takes us to the beginning of the new line. So the difference, again, the difference between carriage return and new line is new line character takes the cursor to the beginning of the next line. Carriage return takes it to the beginning of the same line so that you could overwrite whatever you have printed so far. So let me just execute this so that you can see. You see, we only see go ... on the screen because whatever we did in here, we took the cursor to the beginning of the same line, and then this go has basically overridden on top of those characters. So let me continue. Here I have a backslash b, which is the backspace character. So this is another backspace character. So think about it. Again, the printf is going to print all this, Then I have the backspace character, which is like printing the backspace character on your keyboard, meaning that the cursor is going to go one character to the left, right? So you're basically taking the cursor one character. So if the cursor is here, you're taking it one character back. Then another backspace character. So you're taking the cursor another character back. Then I am printing an E, so it's going to override this AA. Then the new line character, which takes the cursor to the beginning of the new line. So what we should see on the screen is this is a line, and these AA characters should be uh, erased in a sense. All right, so let me execute this, and you can see this is a line. Although we, in fact, printed these backspace characters have kind of removed that. They did not remove it, but the backspace takes the cursor two spaces. We have two backspaces, so we take the cursor two spaces, two characters back, and then print line and E on top of it. That's why you don't see those AA characters on the screen. So let me print my separate. All right, the next one is the tab character, backspace tab, which takes us to the beginning of the next tab stop. So let me illustrate this in the following figure. Assume that this is your screen. Remember, the console screen has 80 characters, and um, at every position, which is a multiple of 8, you've got tab stops. That's the typical convention. So here is your tab stop. So when I am printing this message, remember, this is what I'm trying to print. This tab is tab A, tab line. What's going to happen is after you print this in the first 4 columns of this line, the next tab character is going to take you to position 8, which is the next tab stop. And then you're going to print is, and this next tab character is going to take you to column 16, which is the next tab stop. Remember, every tab stop is a multiple of 8, so it's all divisible by 8. And again, we print A, tab is going to take us to position 24, and that's where we are going to print line. So think of it this way. So every time you print a tab character, you're taking yourself from your current position to the next tab stop. So let me execute this statement so that you see the output. You can see that this is actually 8. So the width of every in a tab block in a sense is 8 characters. So we use the first 4 characters to print this. Then the tab character, the next 4 characters are spaced because tab is taking us to column position 8, and that's where we are printing is. The next 6 characters are now space characters. We are printing A, and we are printing another tab, so that means the next 7 characters will be space characters, and line is printed starting on the next tab stop. Let's now look at our next special character, which is \f. It's called a form feed. It is interesting in the sense that \f form feed takes the cursor from its current position to the same position on the next line. So it's basically jumping one line down, and the cursor stays at the same column where it was in the current line. So let me just execute this so that you can see. So we are printing this. Remember, it starts printing this. The cursor is now here. When we print the \f, the form feed, we are now staying on the same position, but the cursor moves to the beginning of to the next line. So this column, next line, and we print is again another form feed. So the cursor was here, so it just moves to the next line and stays on the same position. And again, a form feed, so move to the next line and stay on the same position. So you print line, and finally print \n to move the cursor to the beginning of the next line. Let's move on. Let's now see how we print a \/ character. The way to print a \/ character is to also escape it. So \/ actually represents a \/ just single \/ character. So let me just print this, and you're going to see that we only see one \/ character on the screen. Printing a single quote within a string, I don't have to really escape it. If you think about it, the reason I had to escape the single quote character inside of a character was because the beginning and the end of a character is marked by a single quote. That's why I had to escape it. I can continue escaping it in here, and the compiler is not going to complain, but I don't really have to escape a single quote characters inside strings. But let me, for consistency's sake, let me also escape it. So let me print this, and you're going to see that we see a single escape character. Obviously, I have to escape double quote characters. Very similar to the reason that I had to escape single quote characters inside characters. I have to escape double quote characters inside strings. If I don't do that, let me just remove this. You're going to see that, and then that the compiler gives me an error. I mean, think about it. We are opening the string here, and when the compiler sees this, it assumes that the string has ended. And then the rest of this thing is supposed to be what? It doesn't mean anything. So if I would like to, that's why if I would like to print a double quote character inside of a string, then I have to escape it. All right, so let me just continue and execute this. Then you're going to see that we are actually printing a double quote character. That ends our discussion on special characters or escape sequences, and that also ends our this lecture. So please put your questions in the comment section, and I would be answering them as quickly as possible.